In this unit, we're going to talk about the properties of trapezoids. First of all, we need to understand what is a trapezoid. A trapezoid is it's a quadrilateral, so it has four sides. It's a quadrilateral with exactly one pair of parallel sides. So here I have an example that clearly, if we name this AB, CD. So AB is parallel to DC. That's what these arrows mean, right? But clearly AD and BC are not parallel. So I only have one pair and I have four sides. So one pair of parallel sides, and then I've got four different sides. Therefore, this is a trapezoid. And the parallel sides of the trapezoid are called bases. So that's a base, that's a base. And the legs of a trapezoid are these non-parallel sides. So for bases, we would have AB as our base and DC as our base. And for the legs, in this case, we would have AD and we have BC because they're not parallel, right? The base angles are angle D and angle C, and angle A and angle B, and those are called base angles. So we actually should do 1, 2, 3, 4 different angles. Okay? And let's see. We said angle A, angle B, angle C, and angle D in my example. So isosceles trapezoids are still trapezoids, meaning in this example I have two parallel lines, one pair of sides that are parallel, but the legs are also congruent. So if we call this EFGH, right? So we've got one pair that's parallel and the legs are congruent. Now we have an isosceles trapezoid. And the mid segments of a trapezoid is if we find the midpoint in here, and if we find the midpoint in here, and now if we connect these two midpoints, and we call this M and N. So my MN is my segment, mid-segment, that connects both the midpoint. And in that case, if you imagine M is a midpoint, therefore this part and this part are congruent, this part and this part are congruent. Here are two theorems. It says that if a trapezoid like this one is an isosceles, then each pair of the base angles is congruent. In other words, angle A and angle B are congruent, and angle C and angle D are congruent. And if a trapezoid have a pair of congruent base angles, then it's isosceles. So if I have congruent angle, just one pair, I can determine that the legs are congruent. Make sure that you finish these follow-ups. I'll check it in class. And here's an example. PQRS is an isosceles trapezoid, so then we know that these two legs are congruent and the base angles are congruent. Find the missing angle measurement, so we have to find all of this. Now, because it's an isosceles trapezoid, angle R and angle S are a pair of base angles, right? So the measurement for R has to equal the measurement of angle S, and therefore both of them are 50 degrees. Now, if I use the same side interior angle theorems, meaning if these two are parallel, same side interior angles have to be supplementary, right? So angle S and angle P have to be supplementary. So angle P and angle Q must add up to 180 degrees. Therefore, angle P and angle S must add up to 180 degrees. So angle P is 180 minus the measurement for angle S. Since I know S is 50 degrees, it's 180 minus 50. Let me write this nicely. Minus 50, I should have 130 degrees. Now, because PQRS is an isosceles trapezoid, P and Q are a pair of base angles. So base angles in isosceles trapezoids must be congruent to each other. So Q is also 130 degrees. Now, let's look at the mid-segment of a trapezoid. The length of the mid-segment of a trapezoid is 1/2 the sum of the length of the bases. In other words, if I add AD and BC together, like here, and then I multiply by 1/2, I would find out the length of MN. So let's look at this. I'm asked to find what is DG. I will call it X. And EFHC is a trapezoid. So if I use this mid-segment definition, I can simply set up DG equals half of EF plus CH. EF is 8, CH is 20. So that's half of 28, which should give me 14. So the final answer is that DG is equal to 14. Okay, so this unit is fairly straightforward. Finish all the follow-up and the checkpoints and finish your IXL practices. Then we're done. Thank you, guys.
This is what I call the bicycle trick shot.